Well, now back to a different topic. So far we had like distance functions and hyperparameters. Now we approach the different views of correlation clustering algorithms. So what are the supported views by the algorithms? And for approaching this question, we first need to clarify which archetypes of views do we actually have. So suppose here this example that we have here, you recognize there's in a three-dimensional data set, this one plane here and this dense plane here. Both of them are within themselves dense. So here we have a local correlation clustering. Local in the sense that we have a local high density that is exhibited by this cluster and a local high density exhibited by that particular cluster. However, both of these linear correlated clusters, they can also lie on one common plane because they have like the same orientation in space and they have the same translation. And as such, they can be subsumed to one common cluster. Now, this one common cluster is one global correlation clustering. Algorithms like, for instance, for C are of local nature, like that we have here, and cache, for instance, as with the example of these two lines that actually can be regarded as one line. They cannot be distinguished by cache. So cache is a global correlation clustering algorithm. Then we have something like density hierarchical. So suppose we have like this dense cluster, there is a much more dense linear cluster embedded into it. And we have something which is dimensionality hierarchical. For this density hierarchical, we do not have yet any algorithms, but for dimensionality hierarchical, we have something like HICO, which detects, like, for instance, in a three-dimensional space, a two-dimensional linear subspace cluster, and on that plane, it detects a linear subspace cluster, a line, a one-dimensional. So basically, we have like local, global, in parentheses, density hierarchical, and dimensionality hierarchical. So if we look here, we have, for instance, subspace correlation clustering is local, Oculus is local, cache is global, and dimensionality hierarchical, because if you check out the paper, strictly looking at it, it detects you in a 3D align, and then it continues with the same min support and will detect a plane, and within a plane a line. And for C is like, for instance, local, COPAC, and LM class are global. So algorithms are capable of detecting local and dimensionality hierarchical, or global and dimensionality hierarchical correlation clusters. So you see it's either this one, or even these two one. But what about algorithms which detect both local and global? So what about an algorithm which can detect local and global correlation clusters at the same time? Why would one actually want to have such a method? And if I think we flip back here at the top right, if you check out then the references, there's a paper that I've written together with a master's student. It was a really cool experience because we thought, okay, one can go ahead and choose on a given data set for C to detect the local clusters, and then like cache to detect the global clusters. So not a big deal. And we recognized no, because depending on how you choose selected parameters, you may detect like one plane which is like this and another plane which is like that, but both of them are not necessarily going to be like on the same global cluster that cache will detect. So if you have two correlation clustering algorithms, one local and one global, it is difficult to synchronize them in such a way that they detect exactly the same local and corresponding global view and vice versa. So this is difficult. And what we did then in order to somehow capture the locality with the one master student was we first applied density-based clustering, so full dimensional, nothing about subspaces. And then within those dense, globally dense or full dimensional dense patches, we started to detect per dense cluster the local cluster by applying cache on these local dbScan clusters that we obtained, and then we used again cache to say, or actually not cache, but what a criterion where we said stitch together those two planes detected by cache if they are similar by a certain threshold. So if they're like this, add them. If they're like that, then do not combine these two subspaces. So through that, we chose only one correlation clustering algorithm, namely cache, and one algorithm to capture density, a global so full dimensional algorithm like DB-scan, and combining those plus a few thresholds, we finally made it to get the local and the global view at the same time. And this may be interesting. For instance, we did there on some stellar objects like dwarfs, pulsars, and so on and so forth. And we recognized, oh, so there are clusters which contain only dwarfs and some which contain only pulsars. However, there are clusters on a global scale which considers both of them like the same. So there must be or can be some relationship between dwarfs and pulsars. So it may be of interest to get the whole picture, because if you get only this or if you get only this, you may miss the other part. Here you would miss that both of them are kind of like related. They have like the same linear correlation, so to speak, the same orientation and translation. And here you miss like the local specialty. Here you miss it that there is a subgroup which exhibits among this a larger variance than among that direction, and on the other way around, like one cluster which has equal variance in both directions. So it is of interest, or there may be cases where you wish to have both of these views actually. And well, this is so far about it. A quite short clip, which only deals with the topic of local and global. What is the take-home message here? Well, that you know what is local correlation clustering, what is global correlation clustering, if somebody would ask you to sketch it, or you get such figures that you know which is which, also dimensionality hierarchical, and that you also know that the current problem, most of them are either exclusively either local or exclusively global, maybe also dimensionality hierarchical, but there wasn't up to now a combination of both views or enforcing both views, and that both views may be actually interesting to have. Well, so far about that short chapter. Stay tuned for the next and last part of these the aspects of a taxonomy regarding the objective functions. So far,